You may have heard of tau in the context of neurodegenerative diseases such as Alzheimer's disease. It is well established that abnormal amounts of tau is pathological in the brain. However, tau is not all bad. In fact, it is crucial in stabilizing the axons of neurons and does so through binding domains located on the tau protein that interact with structural components of the axon. These binding domains can come in repeats of 3 and 4 in the adult brain. My lab is interested in tau in the context of traumatic brain injury. And indeed, in our animal model, we find increased levels of tau. We also find levels of white matter damage. White matter consists of axons and myelin. Myelin wraps around the axons of neurons and protects it and facilitates fast neuronal transmission. Because we find both increased tau and white matter damage, we began to wonder if the two were related, given that tau is crucial for axons. Now, I told you that the human brain has 3R and 4R tau. Well, commonly used laboratory mice only have 4R tau. To address this limitation, we also use a humanized tau mouse line to see if having 3R tau affects outcomes following injury. I was curious about the extent of axonal injury following TBI and how 3R tau affects that. So I looked at a consequence of axonal injury, demyelination. When an axon is injured, the myelin that wraps around it can start to disintegrate or may entirely disappear. To look at levels of myelin, I used a fluorescent dye that binds fat, the main component of myelin. And I looked at it in a structure called the corpus callosum, which is this red band right at the top. The corpus callosum is integral for coordinating the two brain hemispheres. As you can see in the graph, I found significant demyelination in the corpus callosum of the wild-type mice that only contain 4R tau. In the humanized mice, however, that contain both 3R and 4R tau, I did not find the significant demyelination. This surprised me. What is it about having 3R tau in your axons makes them resilient to injury? And more importantly, what does this say about human TBI? TBI is a leading cause of death and disability worldwide, and there are no approved treatments. Could one of the reasons be that we're not modeling axonal injury in animals that share our axons? The human brain has 3R tau for a reason, and in the case of axonal injury, it may even be protective. Thank you.